In this video, we're going to take a look at trigonometric integrals. And in the first example, we have the integral of sine cubed x cosine squared x dx. So when we have an integral that has sine and cosine in it, we want to find which of the two have an odd exponent. And here our sine has an odd exponent. So we want to factor one out because we're going to need it for our du. So we're going to say that the integral is sine squared x cosine squared x, and then I'm going to put the last sine x at the end. And now when you factor out a sine x and use it for du, that means that our u is going to be cosine. So I'm going to rewrite sine squared x as 1 minus cosine squared x using our identity times cosine squared x sine x dx. And now I'm going to make u equal to cosine x, which makes my du equal to negative sine x dx. And then I'm going to move my negative to the other side, so I'm going to say negative du is equal to sine x dx. So now we can rewrite our integral in terms of u. So I have the integral of 1 minus u squared times u squared, and now sine x dx is equal to negative du. So I'm going to put my negative out front and my du, and now I'm going to multiply my u squared through my parentheses. So I have minus the integral of u squared minus u to the fourth du. And now with my negative sign, I can flip the sign of the two terms inside the integration. So I'm going to say the integral of u to the fourth minus u squared du. And you can do this step before or after you integrate, it wouldn't matter. And now we're going to integrate. So I have u to the 5 divided by 5 minus u cubed divided by 3 plus our constant of integration. And now we need to go back and substitute our u for cosine of x. So I have cosine to the 5th x divided by 5 and cosine cubed x divided by 3 plus c. In the next example, I have the integration of tangent 5x secant 6x dx. And in this one, we have a choice because tangent is an odd power and secant is an even power. So we could actually either pull out a secant and a tangent and make our u equal to secant, or we can save secant squared or factor out a secant squared and make tangent our u. And that's what I'm going to do here. So I'm going to say that this integral is equal to tan 5x secant 4x and then secant squared x dx. And now I'm going to use my identity to change the secant 4x into tangent. So I have tangent 5x, and then we have secant squared is equal to 1 plus tangent squared x. So the first step I'm going to do is write it as secant squared x squared secant squared x dx. And then I'm going to have tan 5x, and now I'll have 1 plus tangent squared x squared secant squared x dx. And now I can make my u equal to tan x, and my du then becomes secant squared x dx. So in the next step, we have the integration of u to the 5th times 1 plus u squared squared du. And now I'm going to square our 1 plus u squared. So I have u to the 5th times 1 plus 2u squared plus u to the 4th du. And now multiply our u to the 5th through the parentheses. So we have the integration of u to the 5th plus 2u to the 7th plus u to the 9th du. And now we can use the power rule of integration to finish this problem. So we have u to the 6th divided by 6 plus 2u to the 8th divided by 8 plus u to the 10th divided by 10 plus our constant of integration. And then our final step is to rewrite our answer with our tan x in place of our u. So we have tan 6x over 6 plus tan 8x divided by 4. And we got the 4 by doing 2 divided by 8 plus tan to the 10x divided by 10 plus c. And that's our video on trigonometric integrals.